Beer is the most commonly consumed alcoholic beverage in the world. What gives this favorite beverage its alcoholic content? To find out, we went to Riggs Beer Company in Urbana, where one of the founders of the brew house, a master brewer, showed us the fermentation of a lager beer. Its story begins when the malt arrives at the brew house and is milled. Malt for this lager is germinated white corn and barley that has been dried. Riggs Beer Company uses a variety of white corn that was developed here at the University of Illinois. After this malt is milled, it moves to the wash tun, where it is mixed with heated water in a process called mash conversion. It is then pumped into the lauter tun, where the wort is separated from the grain husks. The wort transitions to the boil kettle, where it is boiled before hops are added. Next, it is transferred to the whirlpool for separation of wort and cooling. The last step before entering the fermentation tank is the heat exchanger. The warm wort is cooled by cold water entering the brew water tank. The fermentation tank fills with the cooled wort. It will be held at a constant temperature of 10 degrees Celsius, cooler than that of most ales. At this stage, yeast and dry hops will be added. Lager uses a yeast strain called Saccharomyces pastorianus. This is a bottom fermenting yeast that is used in the production of lager. The yeast consumes the sugars in the wort and produces two byproducts, alcohol and carbon dioxide. These little yeasts make the alcohol content in this lager possible. As the nutrition stores are depleted, the yeast will clump together and fall towards the bottom of the cone-shaped fermenter. This is called flocculating. Riggs Beer Company uses a traditional process of brewing lagers at 6 weeks. They do not use clarifiers or carbonation stones to speed up this process. They believe this increases the quality and flavor of the beers they produce. The yeast will be harvested from the fermentation tank after about 6 weeks of fermenting. Harvesting yeast occurs in a multi-step process. A hose is attached to the fermenter and a valve is opened. The first pull releases a combination of proteins, hops, and dead yeast, which is discarded. Then, time is needed to wait for the flocculating or clumping yeast to fall down the sides of the cone towards the opening. After waiting, open the valve and release yeast into the yeast drink or a plastic bucket. This is repeated 2 more times. After the yeast has been harvested, it will be homogenized and allowed to sit until most of the carbonation has dissipated. The vitality of yeast will be checked. This is quality control for the batch it was harvested from and ensures productivity in the next batch it will be mixed with. This process begins by taking a sample from the yeast drink into the lab. It will be diluted and stirred, then diluted again and methyl blue is added. A few drops go on a slide and the yeast vitality is observed under the microscope. The objective is to have greater than 95% vitality of yeast cells. The clear ovals are live yeast, the dark blue ones are expired, and this is an oxalate. This slide shows excess of vitality greater than 95%, indicating that the lager this batch of yeast was removed from fermented properly and that this yeast can be used in fermenting the next batch. After fermentation, the beer enters a maturation cycle where it achieves full development of flavors. Then it will be filtered and packaged. It will arrive in the tap room in about 2 months for consumers in Central Illinois to enjoy.